Have you ever felt like you're constantly battling your own home? Too hot in the summer, maybe too cold in the winter, always chasing that elusive, just right feeling
Oh, absolutely.
and trying to do it without blowing your budget or maybe even more importantly, without negatively impacting the planet. It's a real challenge so many of us face.
It truly is. Yeah. That sweet spot of comfort and efficiency, it often seems like a pipe dream, maybe, but honestly, it's far more attainable than most people realize.
hmm
There's a wealth of incredible science out there and innovation, too, that lets us live in harmony with our environment right within our own four walls.
And that's exactly what we're diving into today. Welcome, everyone, to a deep dive into the fascinating world of building materials and home systems, the ones designed to create truly comfortable and efficient living spaces.
Yeah.
Our mission really is to unpack the science, the history behind how homes can regulate temperature, both, naturally through passive design and also through cutting-edge active technology. We're basically asking, what if our homes could sort of breathe with the earth?
Exactly. And to guide us on this, we've pulled insights from, well, a really diverse stack of sources. We've got historical accounts of Adobe construction, for example,
Okay.
deep dives into modern technical analyses of things like geothermal HVAC systems, and even, real-world experiences from online forums.
Oh, interesting.
Yeah, it's a pretty comprehensive look at how ancient wisdom and modern ingenuity can converge, and we'll even connect it to how local providers like Hartzell's Heat and Air are making this comfortable, efficient future a reality for people like you.
Okay, so if our goal is truly comfortable, efficient homes, where do we even start? It's interesting, some of the most profound answers seem incredibly ancient. Let's maybe start our deep dive by looking at a timeless solution that's literally built from the earth. Adobe. Now, I think many people know Adobe as like mud bricks, right? But let's really unpack its fundamental composition and what makes it so uniquely effective.
Yeah, that's a great place to begin. Adobe is essentially a natural composite material. It's primarily sand, clay, and silt,
Okay.
mixed with water and often some kind of organic binder like straw or historically even animal dung.
Right.
What's really compelling about it, I think, is that it's readily available, it's non-toxic, and it's locally sourced. That inherently reduces the energy needed for transportation and manufacturing. So its initial environmental footprint is just incredibly low.
And it has that distinct look, doesn't it? That earthy look and texture. It's so recognizable. It can be formed into bricks, obviously, but you mentioned it can also be used more monolithically, like cob.
Yeah.
For anyone who doesn't know, how does cob differ from traditional Adobe bricks?
Good question. Cob is, well, it's a very similar mixture, earth, sand, straw, but instead of forming it into individual bricks first, you build it up in wet, sort of sculptural layers directly onto the wall.
Oh.
So it creates this seamless, more organic form. But both methods, bricks or cob, they create structures that are incredibly durable. I mean, despite their humble origins, Adobe structures can last for at least 30 years, even without minor repairs.
Wow.
And remarkably, they seem to only get stronger with time as the earth materials cure and harden.
Stronger with time. That's genuinely remarkable. How does that even happen when most materials degrade over time?
Well, it's largely due to the ongoing curing process. The clay particles in the Adobe, they continue to crystallize and bond over decades, especially in drier climates. This slow, continuous hardening contributes to its incredible longevity, which is why we see these ancient Adobe structures still standing today.
Yeah, this is where it gets really interesting for me. We're talking about ancient structures that have literally weathered centuries.
Yeah.
I mean, think about the Great Mosque of Janneh in Mali.
Oh, amazing structure.
Just breathtaking. Built between, 1200 and 1330 AD.
Yeah.
It's one of the largest mud brick buildings in the world.
What?
And it incorporates those rodier palm sticks, not just for structure, but as built-in scaffolding for the annual replastering, which is genius.
It really is.
And it has these clever small vents and really thick walls for natural temperature regulation.
Remember, you think about the Alhambra in Granada, Spain, a stunning 13th century palace just perfectly adapted to its arid climate.
Right.
And then there's Chan Shan in Peru, built around 850 AD. That was once the largest adobe city on Earth. thriving in a dry environment, using resources incredibly efficiently.
It's okay.
And these aren't just isolated examples, Adobe buildings, they've been found all across North America, Pueblo, Spanish colonial mission styles,
Yeah.
Central and South America, Africa, Middle East, Southern Europe, parts of Asia too. What these ancient marvels really show us is that sometimes the latest innovation is just, well, rediscovering ancient wisdom. Adobe isn't just old, it represents this foundational understanding of thermal comfort that's still kind of cutting edge in its simplicity and effectiveness today.
So what is it about Adobe then that makes it so inherently eco-friendly and energy efficient by design? What's the mechanism?
It really comes down to something called high thermal mass.
Okay, thermal mass.
Right. So Adobe bricks have this significant ability to absorb heat during the day, store it, and then slowly release it back at night. And this active thermal regulation, it helps significantly moderate indoor temperatures, which dramatically reduces reliance on conventional heating and cooling systems.
So it makes you rethink what insulation even means, really.
Exactly.
It's not just a static barrier, it sounds like, but more like a living, breathing part of the home's climate control.
That's a great way to put it. It's not just about insulating in the traditional R value sense.
Right, because for our listeners, R value measures how much a material resists heat flow. So Adobe isn't really a great resistor, is it? It's more about moderating those temperature swings.
Precisely. Adobe acts more like a capacitor that stores heat rather than just an insulator that resists heat flow.
Capacitor, okay.
It moderates those temperature swings, keeping interiors cooler during hot days and warmer during cold nights. And this effect is especially powerful when you pair it with passive solar gain, like, having strategic south-facing windows. And that's actually why New Mexico, for instance, shifted its building codes back in the 1980s. They started using effective U values for Adobe.
Effective U values.
Yeah, U value is essentially the inverse of R value. It measures heat conductance. They recognize that Adobe has this unique ability to cycle heat dynamically, something a static R value just can't capture.
Interesting.
So depending on wall thickness, the climate zone, even the color of the wall, Adobe walls can range in effective performance from, say, 2.5 R equivalent all the way up to maybe 22 R equivalent.
Well, that's a huge range. And its environmental footprint is minimal too, which is just a huge plus in today's world.
Oh, absolutely. Adobe boasts a very low embodied energy. We're talking around 0.47 megajoules per kilogram.
And embodied energy is?
Right, good question. Embodied energy is the total energy consumed across a material's entire life cycle. So from getting the raw material out of the ground, processing it, manufacturing, transport, assembly, all of it.
Got it.
So that low number, 0.47, means your Adobe home has a significantly smaller carbon footprint before it even starts operating compared to, say, concrete, which is around 0.94 mj kilogram, or ceramic brick at maybe 2.5 mj kilogram.
Big difference.
Huge difference. And on top of that, it's entirely biodegradable. It returns harmlessly to the earth at the end of its life.
Okay, given all these incredible advantages, what are the main obstacles? Why isn't every house an Adobe house today? What's preventing it from being more mainstream?
Yeah, that's the million-dollar question, isn't it? Well, despite their durability, Adobe structures are susceptible to erosion and damage, mostly from moisture, but also wind and temperature fluctuations, especially if they're not properly designed and maintained. So they need regular inspections, crack repairs with plaster, maybe slurry washes, protective coatings. There's an old saying in Adobe construction, you need a good hat and boots.
Good hat and boots.
Yeah, meaning proper foundations to keep moisture out of the base of the walls, the boots, and generous roof overhangs to divert water away from the walls, the hat.
Okay, that makes sense. And it's interesting how you hear Adobe talked about sometimes as like a poverty material for low-cost housing, but then at the same time, it's also seen as really chic for high-end custom homes. That seems like a fascinating paradox.
It absolutely is, and it kind of highlights how modern regulations and perceptions can inadvertently make sustainable, accessible solutions more complex and, frankly, more expensive than they maybe need to be. Traditionally, Adobe was incredibly accessible, right? A material for everyone.
Yeah.
But now, with maybe overcomplicated government regulations or the need for specific engineering approvals in certain areas, it can become cost prohibitive. And while it is labor-intensive, that also opens up incredible potential for DIY, for sweat equity, and cost savings if the owner is involved in the build.
Right.
Contractor-built Adobe homes, they typically range maybe $80 to $240 per square foot, which, depending on the market, can actually be pretty competitive.
So modern Adobe isn't just about sticking rigidly to ancient methods. It's about smart adaptations, too, to overcome these challenges.
Exactly right. Modern Adobe construction often integrates exterior insulation. You might see like 2-inch rigid polystyrene foam board or maybe spray foam on the outside.
Okay.
This prevents the walls from freezing in colder climates and significantly enhances the thermal performance, particularly in wetter areas. But crucially, it keeps that beneficial Adobe mass inside the insulation envelope where you want it for its thermal benefits.
Gotcha. Keep the mass inside.
Exactly. And for common points of failure, like sealing properly around windows and doors, sometimes traditional methods can fail over time. So modern solutions, like specific types of insulation foams, are often needed for proper sealing because they bond well with the Adobe surface. Oh, and it's also incredibly fire resistant. Adobe itself, the earth mixture, will not burn unless the entire planet ignites, as one source put it.
Huh. Okay, good to know.
So it makes it an incredibly safe structural material, though, of course, other parts of the house roof, furnishings still need consideration for overall fire safety.
Okay, so we've seen how Adobe harnesses the Earth's passive energy for comfort.
Right.
But what if we could actively tap into that stable underground temperature for incredibly efficient heating and cooling?
Right.
That's where things like geothermal HVAC systems enter the modern picture. How exactly does this modern marvel work? How does it leverage the Earth's stable energy?
Yeah, so geothermal heat pumps, they utilize the Earth's stable temperature, which is remarkably consistent just a few feet below the surface year-round. So, unlike Adobe's passive moderation, geothermal actively retrieves the Earth's thermal energy. It effectively moves heat either to your home or from your home as needed.
Feels like a heat mover.
Exactly. In winter, it extracts heat from the relatively warmer Earth and moves it into your house. In summer, it does the opposite. It pulls heat from your house and transfers it back into the cooler Earth. It's essentially a massive, highly efficient heat exchanger using the planet itself as its constant temperature source.
Wow. That sounds like a really fundamental shift in how we condition our homes. So we're basically just leveraging the Earth's existing stable temperature instead of, generating heat ourselves through burning fuel.
You've hit on it perfectly. Yeah.
What are the big advantages, then, of this kind of system?
Well, the primary advantages are really compelling. First, they offer a very long lifespan and significantly lower maintenance compared to traditional systems.
Okay.
The ground loops, the pipes buried underground, for example, they can easily last over 50 years with minimal upkeep.
50 years, wow.
Yeah. And the heat pump unit itself, the indoor component, it typically lasts 20 to 25 years, which is far longer than most conventional furnaces or air conditioners.
Right.
And this translates directly to lasting comfort and pretty substantial savings over time due to dramatically reduced energy consumption and less dependence on those volatile fossil fuel prices.
And I imagine there are significant environmental benefits, too, given that there's no combustion happening.
Absolutely. Because there's no burning fuel involved, there's zero risk of carbon monoxide poisoning in your home.
That's huge.
It is. And no air pollutants like soot or nitrogen oxides or hydrocarbons are released into the atmosphere from the system itself. This significantly reduces factors contributing to things like acid rain and various respiratory health risks. Plus, installing geothermal is generally seen as a major home improvement. It actually increases a home's equity, making it a pretty wise investment beyond just the energy savings. And for those folks looking to get completely off-grid, it can be paired really seamlessly with solar panels for total energy independence from fossil fuels.
Those benefits sound incredibly compelling.
Yeah.
But what's the realistic trade-off? Are there any hidden complexities or maybe common misconceptions homeowners should be aware of?
That's a crucial question, yeah. The main consideration is that geothermal installation is definitely not a DIY project.
Right.
It absolutely requires skilled installers and designers. You need qualified technicians who really understand the complexities of these sophisticated systems to make sure you get optimal efficiency and longevity.
Makes sense.
And while they're highly efficient, geothermal systems still require electricity to run the pump and the fans. So their true carbon neutrality really depends heavily on where your local grid gets its energy.
Ah, okay. So if your electricity comes from coal.
Exactly. If your local utility relies primarily on fossil fuels, then your geothermal system, while efficient, is still indirectly contributing to emissions. If your grid uses more renewables, then it's much closer to being truly carbon neutral in operation.
Got it. And there's the installation itself, right?
Wow.
That involves digging up the yard for the ground loops. That can be a bit disruptive.
Indeed, yeah. There's definitely a temporary disturbance to the yard during the ground loop installation, whether you do horizontal loops, which require more surface area, or vertical loops, which are drilled deeper, there's going to be some excavation.
Okay.
However, the payoff is you don't have those loud, intrusive outdoor AC units afterward, so you get back your quiet yard space, and it improves the curb appeal, too.
That's a good point. So, okay, we've looked at Adobe's ancient wisdom, geothermal's modern ingenuity. We've talked about Earth as a passive temperature regulator with Adobe, and Earth as an active energy source with geothermal. How do these two seemingly different approaches, how do they work together? How do you create the ultimate comfortable and efficient home using both? It feels like the synergy is where the real power lies.
That's precisely it. The key is really a holistic approach, where the building design and the mechanical systems work together seamlessly.
Holistic, okay.
Right. Both Adobe, with its incredible thermal mass and passive design principles, and geothermal, with its active energy retrieval, are just really powerful tools in the toolbox. The goal in modern sustainable building is often to move towards what they call nearly zero energy buildings, or NZEB standards, and also passive house concepts.
Right, I've heard those terms.
Yeah, and they aren't just buzzwords. They represent a philosophy of designing homes that are so incredibly efficient they require very, very little external energy to operate. And this is achieved by carefully choosing materials, like Adobe perhaps, and systems like geothermal, that reduce energy consumption throughout the building's entire life cycle. From the energy it takes to create the materials in the first place, to the energy consumed day to day.
And that's really where having a knowledgeable partner comes in, right? Someone who can actually guide you through these complex choices.
Absolutely essential.
And that's why companies like Hartzell's Heat and Air are such a great real-world example, providing these kinds of holistic solutions.
Exactly. Hartzell's positions themselves as your experienced and reliable HVAC partner right there in central Oklahoma, and they specifically specialize in these energy-efficient geothermal solutions. They're, 45 plus years of proven experience and expertise backed by Oklahoma State University education. It really underscores the importance of having knowledgeable professionals who can design and install these complex integrated systems correctly.
Yeah, you need someone who understands both the building science and the mechanical systems.
Precisely. Achieving that truly comfortable and efficient home means considering both the building's envelope, the walls, the windows, the roof, the insulation, and its mechanical systems, making sure they work together, not against each other. So honestly, for anyone listening in central Oklahoma who's thinking about designing their comfortable and efficient home, talking to Hartzell seems like a fantastic first step. They can really show you the materials and the systems like geothermal that make this comprehensive, holistic approach possible.
And that really wraps up our deep dive for today. We've journeyed from, ancient earthen structures all the way to cutting-edge thermal technology.
Quite a journey.
Yeah. Exploring how ancient building wisdom, embodied in things like Adobe and modern innovations like geothermal HVAC, contribute to creating truly comfortable, truly efficient homes. We've dug into their unique advantages and also the considerations involved in implementing them, seeing how that holistic approach really brings it all together.
And I think as we consider building or upgrading our own homes, the choices we make for comfort and efficiency, they really go beyond just the mere cost, don't they?
They really do.
They involve potentially a deeper connection to the Earth's natural properties and the intelligent application of technology.
So here's a final thought to leave you with. How might rethinking what materials make up our home, from the very walls that surround us, like Adobe, to the ground beneath our feet that geothermal taps into, how might that fundamentally change not only our experience of living day to day, but also our long-term impact on the world around us?
Something powerful to ponder, definitely.
It really is. Something to think about as we all continue this journey toward a more sustainable and comfortable future.